All right, so we're going to look at how do we do long division of polynomials. Now, if you haven't done long division of regular numbers in a while, it may help you to actually go back and review how to do regular long division, because the procedure for the long division of polynomials is actually extremely similar. And so if you remember the one, you'll be able to make the connection, and then this will be a lot simpler. So we want to divide in this example, we're going to divide a trinomial by a binomial. The procedure for working with longer polynomials is basically the same. You want them in order. Typically, we do descending order. If you're working with Taylor polynomials in Calc 2, you may want them in ascending order. But the general procedure remains relatively consistent. If you are missing terms in your polynomial, let's say you have x cubed minus 8 and you're trying to divide something into that, it can be extremely helpful to fill in the missing components, the zeros where you have missing things, in order so the things will line up appropriately. Again, think of it as similar to when you're dividing by decimals. You add in the zeros so that you can divide sort of more normally. But we're going to do just a simple example to illustrate the general process. So here we're going to divide x squared minus 6x minus 12 divided by x plus 4. Now, when you try to, one way of simplifying this, sort of doing the division, would be to try to factor this. But there are no factors of 12 that have a difference of 6. So we can't factor it and then cancel. So the only thing we can do to simplify this expression is long division. So the idea here, we're going to again write the problem as initially a division problem. So the numerator goes under the division bar, and then the thing we're dividing by, the divisor, goes to the left of our division bar. And the procedure for doing division with polynomials, we don't have to think about the whole thing. When we're doing long division with numbers, we think about just the first number or the first 2 digits, or maybe the first 3 digits, depending on how big the number is we're dividing into. Here, we're just going to worry about the leading term. So we're going to divide the leading terms from the thing under the radical by the thing on the thing in the numerator, divided by the leading term of the thing from the denominator. So essentially, we're going to write the expression, the leading term from the numerator was x squared, the leading term from the denominator was x, and then we're going to simplify that expression basically to figure out, well, how many times does x go into x squared? We get x. And so we're going to line up the x above our x in our original problem. So we're going to put it above the division bar, just like when we're doing regular long division, we line up the digits. Here we're lining up the terms. And then the next step is to multiply this number by this number. So x times x is x squared, x times 4 is 4x. And then we write it underneath our divisor, our dividend, the thing we're dividing into, our numerator. And then what we need to do is we need to subtract this. Now, I find it useful, rather than trying to juggle this, thing with a minus sign, I distribute the minus sign through my entire expression, and then I add. Because when I'm trying to deal with a 6x minus a 4x, or if it's a minus, then it's really confusing. I'm terrible with minus signs. So I try to reduce the number of things I have to juggle in my head by distributing and then adding. So distributing a minus sign and then adding is equivalent to subtracting. So I put through my minus sign and I get this. And then when I add, if I've done everything right, the leading term will drop out. Here I have -6 minus 4x, which is a -4x, and it leaves me with -10x. And then I bring the next term down And then I repeat this process until I run out of terms or I can't divide anymore. So I bring down my negative 12. And again, for the next step, I'm just looking at this leading term. So I'm looking at negative 10x and dividing by this leading term, which reduces to negative 10. I put my negative 10 above the constant in my original problem. And then I multiply negative 10 times x is negative 10x. Negative 10 times 4 is negative 40. And then I have to line it up under my original problem and subtract. So here, this is, I'm lining it up under my original problem, but I don't want to add it. I want to subtract it. I'm subtracting it right here. And so again, just to make my life a little easier, I distribute the minus sign so that I don't have to keep track of minus, a minus, a minus. If I distribute the minus sign, this becomes a positive 10x, and this becomes a positive 40 because minus minus cancels. Another minus minus cancels, becomes a plus. And then negative 10x and 10x, again, the leading terms should cancel. If they don't cancel, you've done something wrong. These should cancel, and then negative 12 plus 40 gives me a remainder of 28. How do I know this is the remainder? Because I can't divide x into 28 anymore. There's no more x's. So then I'm done with the long division. Now, if you get a remainder of 0, that means everything divided out evenly. If you don't get a remainder of 0, then some problems will ask you to just write this as R28. So your answer will be x minus 10, R28. Or some problems will have you write the solution as x minus 10 plus the remainder over the original denominator. So then you would get x minus 10 plus 28 over x plus 4.